It's K8BYP Saturday night, nothing on but TV except Black Sheep Squadron reruns. Good show. But I want to finish this issue about these matching networks, which are fake tuners. As I've explained before, they are tuning nothing. Tuning means to adjust something to a frequency. We adjust a VFO to adjust a receiver to a frequency that tunes the receiver. These are matching networks, and I, as a design engineer, have done a series of videos, put them on this channel, of a complete engineering workup calculation of matching networks. That eliminates any question, except to the horribly uneducated among us, whether I know what a matching network is or not. I've done, I think, 4 videos on this topic, and in every one of them, I've done them wrong on purpose. I did them wrong to bring into the topic radio operators myth, like the myth of the commenter that was banned for outright lying about this isn't a problem because finals don't blow up. That is an outright lie, and I won't tolerate lies, because that may lead somebody else to try this and blow up their radio, and we're not going to have that. There's not going to be no trolling and no false information on this channel. We just get banned immediately. Won't put up with it. Don't have to. In those videos, I try to admit both radio operators' fantasy beliefs, which are grossly wrong, and what's also wrong from the engineering side of pretending that antennas and transmission lines are circuits, and they are not. Antennas and transmission lines work in the time domain. Circuits work in frequency. You put a pulse in a circuit, it goes through the circuit all at once, for the most part. Put a pulse into a long transmission line, there's a propagation delay of it reaching the top of the line at the antenna. That's from a TDR. And that's a discrete time delay. That doesn't happen in circuits. And that's proof that lines and antennas are not circuits. Just because PhDs have improperly forced a bunch of high-level math on a topic to try to force circuit analysis does not make it so. It's just in the past, we didn't have the knowledge of how these things work to work it out. This has also been a fault of getting into the 1970s and 80s and onward, where they didn't have computers in the past. And now we've got computers for PhDs to play lots of fantasies with in these monstrously complex electrical circuit calculations on transmission lines and antennas. And it leads to a disaster. But the point of this video is to get off the fence and show you exactly what's happening in an absolute proof, kind of like in the last video, proof of what happens at the feed point when this network is adjusted to make the transmitter look like it's matched. It proved beyond a doubt that putting the fake tuner at the transmitter made the match at the antenna feed point worse. It didn't make it better. It resulted in almost an entirely, almost total reflection. And the SWR meter, which is not, it is reading reflected current, was artificially put at a minimum by adjusting the knobs on the matching network to give a current minimum, but that also corresponds with the voltage maximum, and that's dangerous to the radio. So here's the full color explanation of what's going on here. On the left, transmitter, 50 ohm output, R50. Power level is low enough that the electrical charge is going up that transmission line in the forward direction. FWD going up. There's not so much charge going up that the line can't handle it. There's also room for reflected charges to come back, and they don't collide. When this happens in antennas, there's collision and there's radiation. But let's assume that this transmission line is a bidirectional path or a reciprocal path that will allow forward and reflected to happen at the same time without interfering with each other. And it's possible, but not likely, because it's known that mismatched lines have radiation at the feed point and there's destructive interference. But let's ignore that for now. It goes up, it comes back. Let's assume there's no losses. It all goes up, and what's reflected all comes back. But let's start with a match system. When the transmitter is 50, there's a short R50 coax jumper between the transmitter and the fake tuner, also known as a transmitter fooler by experienced radio operators, which goes to another R50 line. So if the transmitter's R50 and the jumper's R50 and the transmission line is R50, what's the point in having a transmitter fooler there? It isn't doing anything. In order for that system to be matched, each port or each image, the image is the input and the output of the network, must also be R50. If you watch my network videos, I explain this in great detail. A matching network creates resistive images at each port. They cannot be reactive. They cannot be reactive inside the network, and they cannot match external connections that have reactance. So the line coming back from the antenna cannot appear to be reactive, because if it is not valid to use the matching network. But for the initial condition where everything's matched, the transmitter looking into the jumper must look into an R50 input on the matching network. The output of the network must be R50 to match the R50 transmission line, and the antenna feed point looking out toward the antenna must be R50. That's a matched system, but the jumper and a matching network are useless. But they don't really cause any problems. They don't really interfere with anything. Now, in the case that the line, the transmission line to the antenna is R75, then like I've shown you, I have L networks. They work perfectly. Had about a 1/2 SWR on a 20 meter, and I checked it again, and I'd made a wrong calculation on the capacitor. I put the right capacitor in, it's dead flat. But those are L networks. Those are matching networks, similar to the so-called 3-knob tuner, except an L network only needs 2 components. They do the same thing, except for differences in phase. The 3-element network can also match phases from about 10 to 170 degrees. The L network can't. The L network's pretty much a fixed phase. The energy coming from the matching network, which is matched to the transmission line, goes up the line, is emitted by the antenna, nothing returns. So that describes the forward path. When we use it, if we took the transmitter off and put a TDR on it, there would be a pulse, an incident pulse going out. And if there's a mismatch, there's a reflected pulse. But they travel out the line and back at different times. And the incident pulse going toward the antenna does not cross the path of the reflected pulse. It's a single pulse. When a transmitter is generating energy in a sine wave, after the first few cycles, depending on the length of the line, there can be energy going up and back at the same time. And we're going to assume those energies can pass each other without colliding and being radiated. The matching network is reciprocal, so is a transmission line. Reciprocal means it doesn't know what direction is. A matching network that's 75 in and 50 out can be flipped around to be 50 in and 75 out, and it doesn't know and it doesn't care. The critical point is the matching network can only match resistive terminations. So let's say the antenna is mismatched. There's reflected energy. The energy all goes up the line to the feed point. Most of it's emitted. Some of it is reflected. The transmission line has an R50 characteristic. It does not have impedance. Impedance is a series element in a circuit. If there was impedance in the line, it would oppose energy going up the line, and it doesn't happen. The line is known by not its impedance, but its admittance. and admittance losses because a dielectric is effectively a capacitance across a line. And the transmission line is rated at loss in dB per 100 feet. And that's dielectric losses. That is not impedance. Nothing impedes the travel of energy up that line. But energy is reflected at the feed point and it comes back. The line's characteristic, which is R50, R75, whatever, is a function of the ratio of the diameter of the center conductor, the outer diameter of the center conductor for so-called coax, and the inner diameter of the shield. The log of that ratio of those diameters determines that it's R50 or 75. Here's a critical point. It has nothing to do with the kind of energy going up or back. This is not circuits. That transmission line is R50 no matter what it's terminated with, because putting a 100 ohm resistor in place of the antenna does not change the diameters of those conductors, just like putting a capacitor at the feed point of the antenna does not change the antenna. The antenna is matched or mismatched because of its mechanical dimensions, which are mostly length, and nothing at the feed point is going to change that. So there's reflected energy coming back, and it is coming back through a 50 ohm conduit. Just incorrectly pretend that there's two transmission lines, one going up, one coming back. That's not true, but just for clarity, assume there's a separate path coming back. That separate path, that energy coming back reflected, comes back to the matching network, which is R50, and there's no mismatch between the line and the output of the matching network, which now, to the reflected energy, is now an input. Remember, network bidirectional, reciprocal. So that reflected energy goes through the matching network. Now the output of the network to the reflected energy is R50. It matches the R50 jumper and the R50 transmitter, and all that reflected energy ends up causing heat and possibly damage to the final amplifier. Those of you that have used a lot of tube transmitters, you've seen the plates glow red. You tune it for dark plates, and while operating, you watch the plates. If they turn brown or red, you get off the key and go find out what's wrong with the antenna system. There are 4 cases for feedpoint matching or mismatching. The first case is matched, no reflection. In a practical antenna system, there's going to be capacitance at the feed point. There'll be a slight mismatch. On antenna testing, the reflection coefficient, or the return loss, is 30 to 40 dB. There's a little bit coming back, but it's trivial, so we ignore it. The second case is a resistance mismatch. 50 ohm transmitter, 50 ohm transmission line, a 80 ohm antenna. That reflected energy is in phase. That means voltage and current are proportional and the same all the way back the line. The third case is if there's apparently a reactive mismatch, plus or minus X. A reactance at the feed point is completely non-conservative. It reflects everything it gets because reactances can't keep energy. They don't dissipate. The differential equations for inductance and capacitance, V L d I dt and I C dV dt, are reciprocal. They're bidirectional and they have no loss. So the energy goes into an apparent reactance at the antenna and it comes back. And then there's a combination of a mismatch of both R plus or minus X, and that's very common. No matter what the mismatch, that reflected energy may be in phase, it may be out of phase, but it's coming back our assumed separate conduit. So it doesn't collide with the forward, so there's no conflict there. But again, nothing at the feed point changes the characteristic of that line. If you look at Ohm's law, if we incorrectly look at Ohm's law and assume that line is a resistor, our characteristic 50 transmission line, 50 ohm resistor, Ohm's law, V, I, R. The voltage across resistance results in a current. But R is not affected by V or I. R is a material property. It's called resistivity of the material. The voltage and current applied do not change the resistance in any way unless it burns a resistor up. Too much power, resistor fries, it opens up. Similar way, the nature of the reflected energy of one of these three cases above does not change the fact that the line is R50, and the energy in the line does not determine the characteristic R50 of the line. So that energy is coming back in R50 conduit. Now here's where the disaster happens. The uneducated radio operator thinks they're going to throw a fake tuner in, and somehow, by magic which they cannot explain, you will never hear one of these tuner hams or CBers explain what's happening inside a tuner because they know nothing about it. This reflected energy is coming back to a matching network that's already matched. But in desperation, they start twisting knobs and think that they've got a match. And any adjustment of those knobs will take one or the other of the ports of that tuner, one of the other images of that network, away from R50. Now there's a theory, and it's false because it violates conservation of energy. It violates laws of physics, that the reflected energy is somehow reflected again at the matching network and is eventually radiated. And that is a bald-faced lie. Because see, if it's all reflected again, there's no such thing as reflected energy, is there? If it's all eventually radiated, then there's no such thing as reflected, because it's all radiated. This is a transmission line, it's not a circuit. And transmission line properties are the transmission line can be correctly matched with a resistive load and appear to be infinitely long with no reflection. The line can be infinitely long and have no reflection. The line can be terminated in a correctly terminating antenna, which emits and has no reflection. And those are related to these conditions of reflected energy. But when a transmission line is open or shorted, then there's essentially a complete reflection for either case. So the only case that would satisfy this radio operator's myth of all the energy is reflected and ends up being radiated is if the reflected came back and found the tuner missing. It would have to be disconnected, or the output port be such a high impedance that it's an open circuit to the transmission line. But realize it's still in the condition of being R50 in and R50 out. There's no mismatch. The reflected goes right back to the transmitter. It's possible to somewhat consider the transmission line to the antenna as bidirectional. What's really happening is charges are going up and charges are coming back, and they can collide and cause radiation, or they can bypass each other. No such thing exists in a matching network. So anything done to change that network to, say, a high resistive value or high impedance on the output that would result in reflection again of that reflected energy, and it can happen, would also result in a gross mismatch of the energy coming from the transmitter through the jumper. Let's assume the input image is 50, but the output is 900, some ridiculous value. That path of the forward energy is now broken because there's a gross mismatch between the matching network and the transmission line. Where that transmission line toward the antenna connects with the output of that matching network, it's got to be R50 to facilitate the forward transfer, or it's got to be an open circuit to reflect the reflected, and it cannot be either or both. It can be either, but it can't be both. There is no such thing as a magic network that can have an output that's matched for forward but mismatched for reflected. And again, that goes with the fact that networks are reciprocal. They're bidirectional, but you only get one value of R on each image or each port. You can't have three. So the mismatch of the output of the network, under the assumption it's going to reflect energy back up the transmission line, where in reality there may not be collision, but there's going to be loss. My 15-meter dipole with 2 wavelengths of transmission line is seeing a 3 dB loss just going out. That would be for the portion of energy that's reflected, that's 3 dB loss going up, 3 back, and 3 back out again. 27 dB loss. It's all gone. So this idea of reflected somehow gets reflected again and radiated is an outright lie. It's desperately grabbing at straws and opinions to try to justify this insanity of this transmitter fooler, this fake tuner. But now that an uneducated operator has twisted the knobs on this unit and screwed it up so it's no longer 50 in and 50 out, there's a bad mismatch on the transmitter. In the tube days, tube transmitter outputs were pi networks that could be adjusted to accommodate some of this. They didn't generally have protecting networks. These solid-state transmitters are subject to damage from overvoltage. They're sensitive. And in the previous video where I showed the Olson Twins meter, that Yaesu, even with the Drake meter showing a very low SWR to the transmitter, it was still seeing a lot of reflected something because it had scaled back the transmit power, because it knows the load is wrong and it folds back the transmit power so the final stage is not destroyed. So not only is there reflected energy coming back from the antenna to the transmitter, there's also a forward mismatch. And where the output of the network is mismatched to the 50 ohm line, there's a reflection there also. So it is impossible to win this. It cannot be done. The best that can be done is a compromise. I've done it. There are lots of people out there doing it. Their antenna systems are horrid. I've tried it. It doesn't work. But these networks, these fake tuners, can be adjusted for maximum indicated forward power. And that's a compromise in those two directions. It's not all of one, not all of the other. But it's possible to get a marginal increase to twiddle those knobs at random and by guessing to get the maximum indicated power from the transmitter. It's still dangerous. See my video on how antenna system mismatch destroys solid-state transmitters. Those output circuits, the output matching networks, and band filtering networks in these solid-state transmitters can only take so much voltage. Also see my video on why SWR meters aren't. They are not measuring SWR, they're measuring forward and reflected current. And this fake process of adjusting this fake tuner for a minimum so-called SWR between the transmitter and the fake tuner is artificially making a current minimum between the two. Now notice the so-called SWR does not go to zero. That proves there's reflected energy, and the matching network is not matching. And the danger there is that for a given amount of power, power is voltage times current. When the current goes way, way down, the voltage goes way, way up. And that is what kills the final stage. It will quite likely destroy one of the matching network components, and that's the end of it. Because it makes no difference whether the finals blow or a capacitor in the output network shorts. It's all over. So in short, it is a fool's errand to try to play with twiddling knobs on a fake tuner. It will not work. It violates the laws of physics. Amateur radio beliefs with these fake tuners violate the laws of physics, and they're too uneducated to understand the difference. And this is the fault of the $L who have been pushing this myth for decades, including Johnson pushing this myth in a 1958 Radio Operator's Handbook. I have a copy of it. There were cases in the past. There are cases now in broadcast where the antenna system is so hopelessly out of match that there's nothing else that can be done but try to couple some energy into it. But universally, that network must be at the antenna. There's pretty much no operating broadcast antennas without matching networks at the antenna, especially AM broadcast, because the towers are so extremely short they cannot be loaded correctly. But this does not have to apply to amateur radio, where we're running low power and we have control over our antennas. And if we learn something, if you watch my antenna videos, you will learn how to make correctly matched antennas. And I can't stress how unobvious it is, what a radical difference it makes. Because Radio Engineer's Handbook, Terman, says that matching networks become lossy when they're not correctly resistively matched. And due to collision on the transmission line and losses, there's a lot of energy lost in a transmission line. So what ends up going out the antenna is a very small part of what the transmitter has produced. And I can't tell you the hundreds on hundreds of operators I've talked with that have had crappy systems like these, and I've absolutely blown their doors off with QRP. They can't explain it, they get angry, they go off the air, they come up with excuses. Anything but to admit that their antenna system is no good. I just worked Bermuda with a 1/4 of a watt and a dipole. Don't tell me about fake tuners. I'm not going to listen to you. And the same as the fact the matching network here cannot match a transmission line, because what the network is matching is a characteristic of a line. It is not matching the energy coming back. If the energy is out of phase, that network can't deal with it. But in the same way, that network at the feed point also cannot match that antenna if it's messed up, because the antenna's feed point, its characteristic, is determined by its dimensions, and nothing you do at the feed point is going to change that. Moral of the story, do it right. Did it.